Hi, and welcome to the Code Maven channel and the Code Maven meetup group. My name is Gabor Szabo. I'll have to pay attention to the other screen because I broke something. Anyway, so my name is Gabor Szabo. I work I provide training services in Python and Rust, usually to companies. And I also really like the sharing of knowledge among people. So that's why I'm organizing these events. Both we have some in-person events, but in English we have these online events, so everyone around the world can join, and we can also have speakers from around the world. And we are recording this session. So if you are watching in YouTube, then please like the video and follow the channel. And if you are here, thank you for coming, and thank you, Mai, for this presentation. So if you are here in the meeting, then you have the option to ask questions or and comment in the chat room. I'll monitor it, and if you also do it, it's fine. If not, then I'll ask the question aloud if someone is asking questions, and that's it. I think that you have a much better position to introduce yourself, so please, you're welcome.
All right. So first of all, great to be here. And of course, if you have any questions during the presentation, feel free to shoot a message on the chat, and I'll try to respond. As Gabor mentioned, we'll discuss some advanced Python monitoring. So my name is Mai. I'm the co-founder and CTO at HUD, where we're building a production code sensor that helps identify issues in production before they hurt your customers, get to the root cause, and have all the context that you need in order to solve them. And as a part of building this product, we needed to understand really well how the monitoring in Python evolved over the years, because different customers use different versions of Python. And we wanted to share those learnings on what we learned along the way. So today we will go over the different monitoring mechanisms that were evolved throughout the years, and also try to get to a more practical framework on when to use each one of those tools. So what exactly is monitoring? It's a great question. Some of you may use Sentry or Datadog or OpenTelemetry or anything like that. But the main concept is that we don't only want to run the different code that we're looking at, we also want to understand how it behaves in production or even while we're testing. We want to know which functions are called. We want to know how long they're taking. We want to know why they are failing or why they're actually succeeding. And these are the tools that try to allow us to do exactly that in a way that makes sense for human beings. And as Python evolved, or any other runtime, the monitoring mechanisms evolved along with it to allow us to understand what's going on. So let's start with a time travel back to the early days of Python. So we're talking about 1996. The Python version that was around was 1.4, or maybe even earlier. And just to get a better sense of the times, the Billboard's top song in 1996 was Macarena. It's quite a long time ago. And this is where we are introduced with the first two mechanisms called setTrace and setProfile. setTrace allows us to trace every single line of our Python code. If you're using PDB or any other Python debugger, what actually happens under the hood is usually setTrace. And if you're using setProfile, we can now look at the function level tracing and also include calls that happen outside the realm of the Python code, unlike setTrace, which monitors every single Python line. The problem with these mechanisms is that they both have a severe performance hit on the systems. They are not meant to be used in production systems. They were built to help me debug my code on my computer. You know, where we usually start with "this works on my computer." These mechanisms are actually meant for the times where it doesn't work on your computer. And if we're looking right here, this is actually Python code that I'm showing, the original source code. Then you can see that we have this function called trace dispatch that is basically a dispatcher that gets every single line or every single event or call and try to kind of dispatch which monitoring mechanism should take care of that. So the first thing is that all of these events reach the trace function, and they are sorted. If it's, for example, something that we don't want to monitor, we just skip it. If it's a line, we will dispatch it. If it's a CCall, we will want to monitor that. But we have to make sure that every single event is being transferred to the right place that we want to look at. The biggest usage for settrace is, as I said, the Python debugging. So if you put a breakpoint on your PyCharm or anything like that in the last few days, this is what actually happened in the background. That specific line got traced. This event received a different hook and monitoring happened. So every single line can run. To summarize, settrace and setprofile, they see everything. It's good because we don't miss anything important, but it can also be an issue because we can be overwhelmed with a lot of data and a lot of events that we want to trace. It's very safe. And what I mean by safe is that my application still runs exactly the same. I'm only adding monitoring events on top of that. So the business functionality cannot be hurt from that. But the biggest disadvantage is that it causes a major overhead, practically making it impossible to run in a production system where we usually want to care and understand what's going on. If we move slightly forward on our timeline and get to 2003, Python 2.3, this time Justin Timberlake is rocking the billboard with Rock Your Body, and import hooks are being introduced. What you're seeing right here are PEPs, Python Enhancement Proposals, that started in 2002 for new import hook. There was a need to understand and to be able to manipulate Python code as it is loaded to the memory. And this is actually quite a complex mechanism that was evolving throughout the years until 2013 with different adaptations. But the concept remained the same. I want to write a hook so that every time there is a model that's being imported, I would be able to manipulate its code and make a difference. Import hooks allow us to interfere with the model loading process and set the relevant hooks before they run any of the code. For example, if I want to wrap a specific code that I want to monitor, track the loaded modules for security reason, or for example, the application performance monitoring systems, the APMs like Datadog or Sentry or New Relic, usually use those in order to manipulate the code and add the instrumentation before it actually starts running. So how does it look like in action? For example, usually we take Python code, we load it, we compile it to an AST, an abstract syntax tree, and then we compile it directly to bytecode. In this specific example, for example, I can start by compiling with the AST only flag, which means that my code will be transformed from text to an abstract syntax tree that represents my code. And then I can also run a transformer that will transform the way that my code behaves before it is loaded. This is an example for one of those transformers. I basically go over every single function definition, and I append another decorator that calls log function invocations. This will allow me to count the number of times that my functions are being called in a generic way without having to manually instrument every single one. After I finished my transformation, I can now compile my code, and the entire import system will continue to load the function and the code as expected. So I didn't have to actually dive into the details of how the import system works, but I managed to make that change. In terms of usage, if any of you used Datadog or New Relic or Dynatrace in your day-to-day, what usually happens are import hooks on third-party functions and on your own code when you are importing the specific agent that traces. So import hooks require manual work. If I don't define the specific functions or modules that I want to trace and the specific transformation that I want to perform on those, nothing will happen. They are rather dangerous in the fact that they interfere with the code that's run and a part of the import system. So if I have a bug there, my code might actually not load at all or change its behavior, but they are very performant, or at least they can be performant if implemented directly. They are used and supposed to be used in production systems, but you can only see what you know that you care about. Moving back forward in time, we are now in Python 3.6. The year is 2016. We now have async in our Python, which is pretty nice. And Justin is still controlling our lives in the billboards, but a different Justin. And now we have eval hooks. So we had our set trace and set profile. We then advanced to import hooks, which allow us to manipulate a module that's loaded, but we wanted something even more granular. So eval hooks allow us to evaluate and transform frames. And it's basically an API for frame evaluation. For the first time, we get a mechanism that allows us to interfere with the frame evaluation directly and completely replace the code execution logic outside of the pure Python realm. If I wanted to, I don't know what, like print a ASCII art of cats on the terminal, I would still be able to do so. It's a very, very powerful tool. As you're probably seeing right now, we're not looking at Python anymore. Well, technically it is Python, but it's written in C because Python is actually implemented in C. And we have to use C in order to implement the evaluation hooks because they are happening under the hood. And we basically write this logging eval frame, which is being called on every single frame that's loaded on our system. First, we need to understand whether we even want to monitor these frames. The vast majority of the frames are probably not relevant for our monitoring. They could be module loads, class loads, comprehensions, or anything like that. We will then want to log the fact that this call happened, evaluate it, and then log the fact that it ended. It is very, very important to maintain the exception state between these call and the returning one, or our application might be impacted. And it is also very, very important to not run Python code in this code frame because we might cause an eternal loop. And that's not so nice. So if we're willing to go through the distance and gets to importing and implementing this in C, we can enjoy all the benefits of eval hooks. But with great power comes great responsibility. And those eval hooks can see everything, which, as I said before, is good, but could also be bad and overwhelming because we will have to implement some code that runs on every single evaluation. They are still quite dangerous because they manipulate the code before it's being loaded and it is on the critical path of my application. But they can be very, very performant as long as you're willing to dust off your C skills. So what do we have so far? We have set trace and set profile, which are great, but not performant. They are a very good tool for local debugging, but are not scalable. We have import and eval hook, which are dangerous and labor intensive. And if we don't know exactly what it is that we want to monitor, we won't see anything there. So what else can we do? And the truth is, if you were like 10 years ago, you had nothing else to do. But if we're going back in time to where we are right now, getting to 2003 and Python 3.12, which I hope most of you are using in production, maybe even 3.13. Miley Cyrus is probably more familiar than the other ones I mentioned before, because we are quite close to where we're at right now. We have sys monitoring that was introduced, and this is actually meant exactly for these use cases. It's a low impact monitoring system for CPython. And I have to say, it's quite amazing how the Python ecosystem evolved and the fact that they keep on inventing, implementing, and distributing these changes is not trivial. This Python enhancement proposal is meant for monitoring in a low impact, which is exactly the use case in which we want to monitor our Python code in production. So how does it actually work? This is a direct quote from the enhancement proposal, where the proposers say code running under a debugger on 3.12 should outperform code run without a debugger on 3.11. Profiling will still slow down execution, but by much less than 3.11, which is quite amazing when you come to think of it, because monitoring is usually quite extensive. So how does this magic actually work under the hood? Sys monitoring allows us the best of both worlds. It's simple, just like settrace, and it's performant, just like EvilHook. It's a monitoring-oriented API. So as a user or a developer, I can select the specific events I want to monitor, and I can define them in Python. And it also allows for dynamic filtering. So I can look at the different data and select what I care about and what helps me debug my systems. We believe it's probably the future infrastructure of all or the vast majority of modern debuggers, which we will see as Python 3.12 will start being the standard in production systems. So how does it actually look like? What I'm going to do right now is to basically implement PDB and the way that breakpoints are being set using sys monitoring. So the complex logics actually happens at setup time instead of runtime. When I set up the system monitoring, I have to define what exact events I want to monitor and how. So I can actually import monitoring from the module sys and set it up. First of all, I want to set the exact events that I want to monitor. For example, PyStart, PyReturn, PyRaise, PyLine, or any other event that I want to monitor. I set those events so that I will be informed and I can monitor those specific ones. And I also register the callbacks so that once this specific event, for example, PyLine happens, I call my function dispatchLine. Of course, I can also set different functions for dispatching different events, so I can make it easy for me and for the future readers to understand which logics happen when. So let's look at one specific dispatch call. For example, in this case, first of all, I want to understand if I should monitor or not. I can also disable my monitor during runtime, and I can call some function called interact with user in case we call this dispatch function. The concept is that the callback can be very, very minimal. It doesn't have to be very extensive. You don't have to take care of the function's callback or exceptions or anything like that. You just define the events that you care about and exactly what needs to happen back there. The whole concept of the API is to save us from all the trouble of implementing and taking care of the Python deep level stuff. So sys monitoring can see everything, but it doesn't have to, because I can dynamically filter. It's less intrusive because I have a structured API that I can use and rely on. It's well documented and fully supported. And it can definitely be performant, as this is an infrastructure built for that exact reason, to try to understand what's going on. And since people understand that it's not just about looking at the data and at the code when it runs locally, but to actually understand what's going on in production, we have to be able to monitor with a lower impact and stop asking those very hard questions on whether we want to add more logging and hurt our customers with a degraded performance, which is pretty awesome. So in summary, we don't always know where to monitor. And that is a very big challenge, because I want to be able to have the context I need to solve my issues, but I don't always know exactly where the issue will come from. Modern Python introduced a lot of innovation, and throughout the years, a lot of advancement happened, allowing us to never have to choose between the two. And production data can actually shed a lot of light on what our users are experiencing, instead of debugging for hours and trying to imagine scenarios and trying to understand what's going on there without the labor-intensive work of instrumenting my code. So let's try to get it to a practical framework on how to choose which tool to use. So in the x-axis, you can see the completeness. So basically meaning, do I have all the data I need in order to see and solve my issue? On the y-axis, we have the performance aspect. So is this actually production grade in its performance and the impact that it will have on my system and its users? First of all, we have set trace and set profile. If I don't care about performance, that's a great tool. It doesn't matter that it's old. It gives me a very, very high flexibility, and most of us still use it on a day-to-day basis. On the other hand, if I want to be able to run in a more performant way, I have import hooks. They are not complete. I will have to define the specific models and the specific manipulations I want to perform in order to do that. But they are performant enough. If I want higher completeness or a specific granularity, evil hooks allow me to define exactly what I want to do. They enable me to dynamically manipulate or filter or make those decisions, but I have to write that in C or it won't work. If we're using modern Python, I have sys monitoring, which allows me to enjoy the best of both worlds with a system that's performant, complete, and easy to use, but it's not going to work on older versions of Python. So it's a really good excuse to start getting that refactor in place. Around the corner to the top right, there's a big question on where this is going next. There are multiple enhancement proposals in place, but personally, I do believe that sys monitoring is going to allow us quite a lot of wiggle room and a great advancement in our ability to understand what's going on in production without having to slow down or pay the bill on a lot of manual work. So I guess we'll have to wait and see where this thing leads. And of course, we have the different APMs and other observability products that build on top of that and help us understand what's going on. But Python really is very advanced in its abilities to debug and monitor, which is pretty awesome. And I think once you know these mechanisms, it's just another tool on your toolbox to be able to choose the right tool for your specific use case. So I hope that made sense and that you learned at least one thing that you didn't know before. Thank you very much. And feel free to contact me with questions either now or later on LinkedIn or on email. And thank you.
Thank you very much for this presentation. People were like, okay, all silent, and then no one asked any questions. I would like to know, so who is going to be on the billboard, on the musician when the question marks come in place? So if we know that, probably we can deduct what kind of Python package we are going to use. We have some questions now. If you have to target and support multiple Python versions, how would you go about choosing which monitoring system to use?
All right, so that's a great question. First of all, if you want to support multiple Python versions, I would usually start with the lower common denominator. And for example, when we look at HUD, we are bound to the customer's Python version. So for example, some of our customers are still using Python 3.5 or 3.6. In those cases, we would have to use the tools that we have on that specific version. And it's also important to note that some of the mechanisms got better in time. So it's very important to read the documentation and understand which monitoring mechanisms are around. I would still advise to consider sys monitoring, even if just a fraction of your Python versions are supported there, because it's really, really easy and way more performant. So I think it comes down to the question on whether we want a single solution that could work for every single version, or are we willing to fork our abilities and to build better systems for the more advanced Pythons? And that's a question that really depends on the specific setup that we have in place. And I would say that import hooks are probably the most commonly used for production use cases, since eval hooks require the C code that's a little more complex, and they usually don't have, like, you need a very specific use case to actually need evaluation. So I would start with the import hooks as default, or even trying to find some tool online that can answer that specific ask that you have. Regarding the question Are there comparable evolutions of monitoring API in other tech stacks, such as Node, Java, or .NET? So that's a great question. Short answer, yes and no. I think that Python specifically is doing a very, very extensive job, and it's evolving much faster than other mechanisms. On Node, specifically on V8, we do have some more modern functionalities that allow for dynamic tracing and stuff like that. The specific frame evaluation is something that is not as common when you're talking about Java or .NET, that are languages that are not interpreted, but there are a lot of mechanisms that enhance the performance, specifically for system monitoring, or basically an API that allows you to register in specific callbacks. So there are equivalents in Java and other runtimes, but in my opinion, this is the most advanced one.
Yeah, so we have a comment about the status of Python versions, that 3. Lower than 3.9 receives no updates, and lower than 3.12 only receive necessary security updates.
So it's very important to remember that keeping your Python up to date not only helps you with advancing and enjoying all the advancements of Python, it is also the secure way to go, because some of the security patches and other performance hits are just not backported. So there are many, many, many reasons why it makes sense to keep up to date. And I think if I can add, just as a CTO of a company, it's always hard to find time to do these things. But once you skip 2 or 3 versions, it becomes much, much harder to upgrade. So just try to stay up to date and find the time to do that grooming. And above the security necessities, which are also very important, it's a great opportunity to enjoy all these features. And I think just going over them, knowing what's new and what could benefit you, could also be a great way to communicate to your management and to find the priorities to help these changes happen. So great comment.
I have actually a related question comment. So one of the things that I help companies with is introducing testing. And part of what I saw at a number of clients, that they didn't upgrade to the newer version of, well, in the older days it was Perl, nowadays it's Python, partially because they didn't know how to verify that their code base works. So my answer to those companies and to those people were, okay, so invest in test automation, in testing your code. It will also help you with the upgrade. But I wonder what do you think, because you said as a CTO in your own company, what are the most important things that people and companies can invest to make it easier for them to go to do the upgrade? So what are the biggest blocking things in upgrades?
So first of all, I'll mention that we are still rather young. Our company exists for around a year and a half. So we still have the perk of staying up to date. But I do think, and I'll share some of my experience from previous companies, I think that it's just around staying on the wheel. Once you lose track of what's going on in the latest versions, it's very, very hard to step back up. And for that, I think that schedules can really, really help. Using tools like Dependabot or other alternatives that can just raise it back to our awareness that there was some update. If you can join the release channels on the specific runtimes or even the frameworks that you're using, it's not just about Python version, it's also about the framework version, whether that's Django or Flask or even the libraries that we're using. Those can have critical changes that can hurt performance, or even one day you might just wake up and listen and learn that some of the functionalities that you're building on are now in end of life status. And it's very hard to react to that in hindsight. I think the right processes in place should require upgrading and just knowing what's going on in the latest version. So that's like the easy answer. I think tests are also another component, because what we're trying to build is just that sense of safety that we can bump a version or change something and feel comfortable that our systems are still going to operate. And the more time these tasks take, the harder it is to squeeze them in. So when I look at that from a system and a process perspective, I try to ask myself, what takes time? Is it because I'm not confident and when I change stuff? Is it because my software development lifecycle doesn't work? Why wouldn't it take me 2 hours or half a day to upgrade the version? And when I find these places where I have very old legacy code that doesn't support it, where I have lack of testing that requires manual work, when I have some compilation or CI issues that are flaky, these are the places I try to target because they can interfere with the velocity of my entire organization. So just trying to find that bottleneck and to see what I can do about it so that it will be easier for others to do it as well. Instead of those like testing fest or like once every 3 months to invest a day or something like that. I want it to be easier enough. And once it's easy, people would actually streamline and do it as a part of their day-to-day.
Mm-hmm. Thank you. There is also a question that you don't have to answer now with a yes and no. We can discuss it later. If we would be prepared to run a more hands-on session, perhaps including building some example of the new 3.12 possibilities.
So I think that could be a really cool idea, and we can definitely discuss it. And the specific person who asked it, feel free to DM me on LinkedIn. We can try to find a solution for your specific use case as well.
Okay, great. But I would love, I mean, I personally would love to have an open session like this. We'll discuss it later, okay?
Yes.
Any more questions which are more or less on topic?
Yeah.
Like,
hit me with anything.
Yeah. Yeah, Gabor knows how to contact DN. Yeah, okay.
Awesome.
It seems that no more questions now. So again, thank you very much for your presentation and for answering the questions and spending time with us. Thanks everyone who joined the meeting and asked questions or just watched it. And thanks everyone who is watching the video and liking the video and sharing it with other people. And so I'm now going to turn off the video. So thank you very much. And then if anyone wants to stay around and have another more chat like thing, you're welcome to stay. So thank you very much and bye-bye.
All right. Awesome. Thanks.